So suppose that f of t is the function in t, then the Laplace transformation of f of t equal to 0 to infinity. So t power of minus st, then f of t into dt. Okay. So this is the Laplace transformation. And we discussed some formulas. That last class we discussed some formulas about the Laplace transformation and inverse of Laplace transformation. Okay. Uh, So I will share the one PDF more. So we'll discuss. We are following the PDF problem. Some problems will be there. So we have to follow that the formulas. Uh, okay. And before that, yeah. So that Laplace transformation. The Laplace transformation of t power of n. So what is the Laplace transformation of t power of n is become n factorial by s power of n plus 1. Okay. Then what is the inverse Laplace transformation means? So it is coming to the here, that is t power of n by n factorial. That is inverse Laplace transformation of 1 by s square n plus 1. So this is the thing. Okay. Now we'll do some problems about this one. See, I will close the PDF. Yeah. So by using the first operator theory, and the last class we discussed some, uh, this is inverse Laplace transformation, and we discussed the some formulas. Okay. Now let's see the piecewise continuous function, the Laplace transformation of the piecewise continuous function. And these problems are very important for the examination. For that examination, that is a very important. Okay. And this is also example problem. So this is the example problem in your textbook. Okay. So find the Laplace transformation of the continuous function f of t equal to e power of t when the theta is in between of 0 to 1 and it is 0. Okay. And it is 0 when t is greater than to 1. That means what is that? That is t is in between of 1 to infinity. Okay. So that 1 to infinity. So we can say that. Now the Laplace transformation of e power of infinity and e power of minus st f of t into dt. So 0 to infinity we divide into 0 to 1 and 1 to infinity and e power of st. So here they given that function. When the function is in 0 to 1, the function is defined by e power of t. Okay, when the function is more than to the t is more than to 1, that means if the t is in between of 1 to infinity, the function is what is that? 0. So that's we are writing to here. Okay, now let's see here. Now, so this is 0 to 1 e power of, so bases are equal, no? So we are adding the powers. So t into 1 minus s into dt plus 0. And we have that integration formula. E power of ax into dx. So that is become e power of ax by a. Okay. So when you apply to the limits, so when you are applying to the limit 0 to 1, so then finally we are getting this one. Apply the limits 0 to 1 when you are applying to the 1 year and when you are applying to the 0. So that e power of 0 that equal to 1. Okay. So e power of 1 minus s minus 1 by 1 minus s is power of. So if you are taking the minus is common, so minus of s minus 1 minus 1. So this is uh, the example problem. Okay. So see here, one thing you should remember. That there is a function. Uh, See the Laplace transformation of small f of t. See the Laplace transformation of f of t. That is, we come to the capital F of s. Okay. And similarly, that is become the inverse transformation of f of s equal to that is become small f of. Okay. So this is the things. So I would say that here. So they given that f of s, that 1 by s plus 2 by s square minus 3s by x square plus 4 by s square plus 16. Now they are asking to that inverse of. So inverse of f of s. So that's become the L inverse of 1 by s plus 2 by x square minus 3s by s square plus 4 by x square plus 16. Okay. So we know that Laplace transformation of 1 equal to 1 by s. Yes, na? So then it's come to that inverse. That 1 is become inverse of 1 by s equal to 1. Okay. So the inverse Laplace transformation of, and it's in same thing. This is also. So we are using that Laplace transformation of t power of n. What is the t power of n? That is n factorial by t power of n plus 1. So this is the things we are doing. Okay. And this is, we know that cos 2t formula. And this is side 4t formula. Okay. So in the same way, here also one more problem is there. So remember one thing, this Laplace transformation or linear Laplace transformation. So both are using the formulas. So if you are perfect about the formulas, and you can do the any problem. Okay. So we practice on formulas. So the formulas are very less, like t power of n, the Laplace transformation of t power of n, the Laplace transformation of sin at, the Laplace transformation of cos at, the Laplace transformation of e power of a t. So this is the uh, formulas will be there. So then you are getting to the easy. So these all are that example problems, ma. Yeah. Next, the find the Laplace transformation of f of t equal to t into sin at and f of t equal to t into cos at. Ah. See, let's take f of t equal t into cos t. Then Laplace transformation of cos at. So that is nothing to what is that s by s square plus a square. Then the Laplace transformation of t into f of t, that is become the Laplace transformation of t into cos at. That is nothing to what is that minus d by ds into capital F of s. So what is the capital F of s? That means the Laplace transformation of cos at. So the Laplace transformation of cos at is nothing to what is that s by s square plus a square. Okay. So this is the things. So now we are using that u by v formula. So the derivation of u by v. What is that u by v formula? U dash v minus u into v dash by v square. So that's we are getting. So we are doing that derivation with respect to s. So that is become s square plus a square minus s into 2s by s square plus a square whole square. So that is become minus of a square minus s square by s square plus a square whole square. So that after simplification and we are getting what is that s square minus a square by s square plus a square whole square. So this is that the linear transformation of the L of cos 8. And it's in the same way you can find out the T of e power of 8. Okay, these are the formulas. Yes. Now using the first shifting operator theory, so we need to find that uh, L inverse, that inverse of Laplace transformation. Okay. So here that capital F of s equal to 1 by s plus 2 whole square. So that inverse of f of s equal to uh, inverse of Laplace transformation 1 by s plus 2 whole square. And we have one theorem will be there, first operating theory. So I will show that thing. There, here. First shifting operator. So this is okay. The Laplace transformation of e power of at into f of t equal to f of s minus a. No? So in the case, so we'll go to that problem. Yeah, so this, so that we can 1 by s plus 2 whole square, that we can write e power of minus 2t is outside, the Laplace inverse of 1 by x square. So inverse of 1 by x square, that is become t. So e power of minus 2t into t. Okay, that no need to check that everything. Just we are doing that. Yeah. So next problem. Find the Laplace transformation of 1 by s square plus 2s plus 5. That is the Laplace transformation of 1 by x square plus 2s plus 5. No? So that we can write x square plus 2s. That 5 we can write what is that? 1 plus 4. So 5 we can write what is that? 1 plus 4. So this we can write what is that? S plus 1 whole square, then plus 2, 4 equal to we can write 2 square. So now multiply and divided by 2, then become 2 by s plus 1 whole square into 2 square. So when you are writing that is outside, that is e power of minus t. Okay. So completely that is become 2 by s square plus 2 whole square. That is nothing to 1 by 2 e power of minus 2 minus t into sine 2t. Okay. Next. Uh, the inverse transformation of s minus 3 by s square minus 6x plus 13. So this is will come L inverse, the Laplace transform on s minus 3 into simplifications. First, we need to make the factorization here. So in that 10th class standards, we have that how we can do the factorizations, fractions. This is the general things we know as a 10th class standard and intermediate level. After getting a comma b values, just we are substituting here and we are using that formulas. That's thing. Nothing will be there. and that L inverse of S by S plus 1 whole square. Yes. So here the find the inverse Laplace transformation of S by S plus 1 whole square. So that f of s equal to s by s plus 1 whole square. So adding the 1 and subtraction the 1. And we are getting s plus 1 by s plus 1 whole square minus 1 by s plus 1 whole square. So here that using the first operator theorem. So that's we can write e power of minus t outside and that n inverse of 1 by s, and here also e power of minus t outside, that is 1 by s square. So finally we are getting this one. So the Laplace transformation of 1 equal to 1 by s. So similarly the inverse Laplace transformation of 1 by s equal to become what is that? 1. So that become here the 1. So e power of t into e power of minus t and minus e power of minus t into t. So this is a 1. So if we are finding the Laplace transformation of f of t, so again we are getting to the same answer. That is only. So the next topic is differential equations. So here the differential equation topic. Yeah. So the next topic that applications of differential so that applications of Laplace transformation to differential equations. Okay. So how we can solve the differential equation that using the Laplace transformation. So that is the things will be here. So how we can use that Laplace transformation? We can solve the differential equation. Okay. So in that examination, this is very important problem. So how we are solving that differential equation? Generally, We solve the differential equations by using the integrating factor or variable and separable. And in the UG levels, we have that how we can using the method of variation of parameters and their Cauchy-Euler equation. If it is linear differential equation, if it is exact differential equation, so we have the solutions. But here, but using the Laplace transformation formulas, so how we are solving that differential equation? So that is a very important. And in the examinations, so we can get easily for long answer, and it's very easy problems will be there. Okay. Now we'll do some example problems in your test book. Okay. So use Laplace transformation. So solve y double dash plus 4y into e power of t. Okay. And they are giving the initial condition y of 0 equal to 1 and y dash of 0 equal to 1. Okay. So we had to solve this differential equation. Okay. Now see the solution. Now apply the Laplace transformation on both sides. Plus 4 into Laplace transformation of y and the Laplace transformation of e power of t. Okay. So for anyone that Laplace transformation of the y double dash. See, remember one thing, the Laplace transformation of the y double dash and Laplace transformation of the y dash. So before you have to learn what is the Laplace transformation of the y dash and Laplace transformation of the y double dash. So here they are giving that Laplace transformation of the double dash, no. So that is nothing to what is that s square and y of s, okay, minus s into the y of 0 minus y dash of 0. Okay. For any problem, so we can take this one, y double dash equal plus next 4 into. So that L of I that we are taking that y of s, the Laplace transformation of L of I equal to, though now we know that Laplace transformation of e power of t and 1 by s minus 1. Okay. Here, so y of 0. So already that y of 0, they given the 1. So that y dash of 0. Okay, then after simplification, and we are getting what is it? S square plus 4 S power of 4 y of s equal to, this is s minus 1. So 1 by s minus 1. So from there, so from we can write y of s equal to 1 by s minus 1 into s square plus 4. Now we have to do the factorization. So after we are doing the factorizations, so this we can write after doing the factorization 1 by 5 minus 1 by 5 into 1 by s square plus 1. So now after that, we are getting to apply to the inverse Laplace transformation and we are getting to the solution of uh, the differential equation. Okay, na? So here some problems are there. So we just remember this one. So Laplace transformation of y dash t. This is s of y of s minus 1. Okay, so this is. Now this is that one more problem is there. So using the Laplace transformation method and solve the differential equation y dash minus y equal to t, and they given that y of 0 equal to 0. Okay. Now apply the Laplace transformation on both sides. Okay. And we know that the Laplace transformation of y dash is what is that? S into y of s minus y naught. And the Laplace transformation of y of t is y of s. And the Laplace transformation of t. So we have that formula is what is that? Laplace transformation of t power of n equal to what is that? N factorial by s power of n plus 1. Okay, so this is the thing. Yes. So y of 0 equal to the given 0, no? So we can substitute the 0. So from there, so take y of s is common. So that become 1 by s square into s minus 1. Now the Laplace inverse Laplace transformation of 1 by s square into s minus 1. So we have to make the partial fractions. So that become a by s plus b by s square plus c by s minus 1. So this is then we know that. So y of t equal to minus 1 minus t and e power of t. So we are doing the verification. So this is a linear differential equation in y. So that integrating factor that is, you know. and solve that y dash minus y equal to e power of t, given that y of 0 equal to 1. Okay. So solve y dash minus y equal to e power of t, comma, that y of 0 equal to 1. So the Laplace transformation of y dash minus the Laplace transformation of y equal to the Laplace transformation of e power of t. So the Laplace transformation of y dash. So just now we discussed about now the Laplace transformation of the y dash. Okay. So just we have to substitute there and L of y. So L of y means that is nothing to that L of s. So here the one problem is there. So this is s into y of s minus y naught, then y of t equal to y of s, and the Laplace transformation of e power of t equal to 1 by s minus 1. Okay. Now y of s, take the y of s is common. Let's become s minus 1 equal to 1 by s minus 1. So after that, y of s equal to become 1 by s minus 1 whole square plus 1 by s minus 1, and apply the inverse on both sides. Then we are getting that inverse Laplace transformation, and 1 by s minus 1 whole square. Then e power of t into L inverse of 1 by s square plus e power of t. So that is become e power of t into t plus e power of t. So that is become e power of t into 1 plus t. And you should remember the theorem, the convolutions theorem, that f of t star g of t equal to. So here the Laplace transformation. So the problems based on the problems are based on differential equations, and it is very important for the long question. Okay. So in that Fourier series and Laplace transformations, and we have this thing. We have the one more problem. So these are the problems. Just you need to practice this one. Uh, just one. Just I will share that one more PDF now. Just wait. Just wait more. Just wait now, please. So this is the Laplace transformations. Just wait. And next we are going to discuss about the Z transformation. So in the init 9 only we have that thing. So that's we have that. So home kill and jet transfer. Okay. Just I will share the PDF. Ma. Just wait. Ma. General. Hankel transformation. See here, see the Hankel transformation and Z transformation. The Hankel transform of integral function f of r. Okay, for so r is in between of 0 to infinity. So as defined as, so that is the defined as the h1 of f of r equal to 0 to infinity. So r n into, so Jn of that means the Bessel's function and into f of r into dr. Okay. Uh, so there are some properties will be there, and but we are going to discuss about the problem. Yeah. So we'll go do one problem. So find the Hankel transformation. Schedule.
స్కెచ్చా ఏమైనా వస్తుందా
Hankel transformation of so f of x equal to 1 when that is x is in between of 0 to a, and it is 0 when x is greater than a, and at n equal to 0. Okay. So now let's see here. See the solution. And we know that we know that by definition. So by the definition of that Hongel function that we can write, what is it? At n equal to 0, no? So that we can write in place of n, we are substituting 0 of f of x equal to 0 to infinity, that x into f of x and the j naught of the Bessel function, that s of x into dx. Okay. And next. So, but here that f of x equal to 1. No, so f of x equal to 1. So that's is become 0 to a. That is become x into. So this is become 1. So this will become 1. So that is become x into j naught of s of x into dx. Okay. And when you are coming to the Bessel functions, so we know Bessel function. So as per the Bessel function, that we have one formula will be there in ordinary differential equation. In that you learn in that first semester, first year, sorry, in the differential equation. So d by dx into x power of n into jn of x, jn of x equal to, that is become x power of n into x power, any x power of n into अरे so in this case, so that's become when you are substituting that n equal to 1 year. So if you are substituting that n equal to 1 year, so n equal to 1 year, hence we are getting d by dx x into j1 of x is equal to x into j naught of x. So when you are substituting that n equal to 1 in this equation. Okay. Now if you are, so if you are, that is become to 1 by s into. So just in place of x, if you are substituting sx, so if you are multiply and divided by with s, so this is 1 by s. That means the functions we are changing into s of x. So that is s of x. This is become s into s into. So this is s of x. Okay. So therefore from there we can write what is it? 0 to a x into j naught of s of x into dx, that become, so that s will become to the here. So that is x by s into, so j1 of sx, and apply to the limits 0 to a. So that's we are getting a by s into, so when you are substituting a in place of x, so a by s into, so that's become, so j1 of sa. Okay, so this is one problem of find the linear transformation of the that Hankel functions of the one problem will be there, and we'll do the one more problem. And see the next that inverse of the Hankel functions. That one problem is there. The find s square e power of minus s and e power of minus as for n equal to 1 and a is greater than b. So as per the definition, so n equal to 1, no. So as per that n equal to 1, that is become h1 whole power of minus 1 and s power of minus 2 and e power of minus as equal to 0 to infinity s into s power of minus 2 and e power of minus as, so j1 into s into r into ds. Okay. Now here s into s minus 2. So completely that we are getting 0 to minus infinity. Sorry, plus infinity that we are taking that. S into s power of minus 2, that is become 1 by s. So 1 by s into, so e power of minus as, that j1 of r sr into ds. Then we have that one formula is there. So that's why we are getting that 1 by r into under root of r square plus a square minus a. Okay. So this is that Hankel function, and now we are going to discuss about Z transformation. Yeah. So what is the Z transformation? So Z transformation is the one of the several function of the form, especially that for the sequences and series. So what is the use of the Z transformation means? So this is the essential mathematical tools used in the engineering and some applied sciences. Okay. Now we'll discuss about the Z transformation. So first, the Z transformation of the sequence. So the Z transformation of the sequence that f of n. So Z transformation of the sequence f of n as the function as the function capital F of Z. So then we are getting the Z transformation of the Z transformation of the f of n, that is become f of z, capital F of z equal to the series, that is become n equal to 0 to infinity f of n into z power of minus n. f of this n equal 0 to infinity, f of n by all power of z power of n. Just I will. So this is, so we are doing one problem. Uh, See here the one problem, let's see. So find, the Z transformation of f of n, the sequence f of n, where that f of n equal to a power of n. Okay, the series that f of n equal to a power of n. So before we have one, here is the, no? So this is no, so the z of a, this is the solution. So that z of a power of n, the z transformation of a power of n equal to the series n equal to 0 to infinity, that f of n. So f of n is nothing to what is that? A power of n. So that a power of n by z power of n, that series summation of n equal to 0 to infinity a by z, that whole to power of n. And we are in series, that 1 by r power of n is convergence to 1 by r. So that's we can write 1 by 1 minus a by z. So that equal to z by z minus a. So this is a z transformation. Okay, ma, is it clear that everything? So this is the Z transformation. And in the same way, we have to do some problems. So mostly you should remember one thing. Whatever may be, if they are asking to the Laplace transformation and Z transformation, so you should remember the formulas. So if you remember the formulas, so remember one thing, the formulas are very important. So the formulas, so the formulas are very important for the Laplace transformation and whatever may be Z transformation. Okay, the Laplace transformation and Z transformation. So you should remember that formulas and making that partial fractions. That one more thing you should remember, that partial fractions. So this is in ninth class, 10th class in the standard it will be there. The partial fractions, how we can make them. So one thing you should remember the formula and how we can do that making the partial fractions. So that is enough for that Fourier transformation, either linear transformation, either Z transformation. So whatever may be, so these two will be that most important for that Fourier transformation, Laplace transformation, whatever may be. Okay, students? Yes, ma.